So I'm looking here at question number 85. We're solving for x. So I see that it's x to the third power. So I'm looking for 3 different values for x. My estimate is that no one has gotten to question 85 yet. So looking at this, I see that it's a trinomial, and presently I do see a GCF of x. I begin by taking that x out, and I'm left with 3x squared plus 5x minus 22. And I'm getting nervous because I'm not sure if this is going to factor. I go to make my t-chart for this trinomial. The b value is 5, and the AC is going to be negative 66. Oh, phew, this will factor. So the numbers that multiply to 66 that then add to 5 are going to be 11 and 6. To make that positive 5, I want the 11 to be positive and the 6 to be negative. And then I'm going to use those to split the middle term. So instead of 5, it's going to just be 11 and 6. So now I'm going to rewrite this as 3x squared plus 11x minus 6x minus 22. I'm leaving out that beginning x as just one of the factors for my last step. So now I have 1, 2, 3, 4. So underlining the first 2, drawing up, and then the last 2, I'm drawing the fence to help me visually segregate the first half and the second half. With 3x squared and 11x, we're going to divide both of those by x, taking the x to the outside, giving me 3x plus 11 as that first binomial. Then looking at the last 2 terms, I see that the 6 is negative, so we're going to take out a negative, and it looks like I'm just going to be able to take out a negative 2. Bringing that negative 2 to the outside of parentheses, that's going to become positive 3x plus 11. Excellent. Looking at my binomials, they do match, so I'm feeling really good. I've got x minus 2, 3x plus 11, and I didn't forget about my original x equals 0. Not done yet. Now I've got to set each factor equal to 0 according to the zero product property. So that's x is equal to 0. Check. That's my first answer. Then I have x minus 2 is equal to 0. So I add 2, and 2 is my second answer. Finally, I have 3x plus 11 equal to 0. So I subtract 11. Then I divide by 3. And I get my third answer, negative 11 over 3. So x is equal to 0, 2, and negative 11 over 3. That matches with my degree of 3. So far, so good. Okay, so that was 85. Let's take a look at 86, which I see the word log. So right away I can tell totally different strategy here. This is a log equation. In this case, I'm going to need to combine both sides to a log equals log. We're using properties of log. The first property I think of is this one here, the 2. That 2 is on the outside, and that's going to pop up to become an exponent. So this is going to be log base 9 of 4 plus log base 9 of x squared is equal to log base 9 of 20. The next rule I see is the addition of logs rule, right? That's the log A plus log B will simplify to a single log of A times B. So that's going to be log base 9 of 4x squared is equal to log base 9 of 20. Right on. This is log equals log. So since that's true, the logs are now gone, and I have 4x squared is equal to 20. I divide by 4, and I have x squared is equal to 5. And I normally would solve this and get 2 answers, meaning plus and minus rad 5. So I'm going to take the square root here, and I normally, right, I'm going to get x is equal to plus or minus rad 5. However, this is a log. So if I plug in to this original x a negative value, that doesn't work. So this negative is not needed. We only get x is equal to the square root of 5. Because the property of logs is that no negatives are part of the domain. 0 isn't even part of the domain, or you can't plug in those values for logs. All right. Fun properties. Let's take a look at 87. My computer is thinking about that. I think it's thinking that might be a hard one. No, looking at it, it looks great. I love it. I count up this. I see that it's a degree of 3. I'm looking to find 3x values, and I count up 1, 2, 3, 4. These are my favorite factoring problems because they look gnarly, but then I just get started right away by drawing the fence. Looking at these first two, I see that they both have x squared. So taking that x squared to the outside, I'm left with 2x minus 5 on the inside. Then looking over here at 8 and 20, I'm going to be able to divide both of those by 4. That's a positive 4, which it just helps me to exaggerate which sign it is. So I'm going to put plus 4, and then that would be 2x minus 5. Excellent. My binomials match. So now I'm going to write these together as x squared plus 4, and then 2x minus 5, back to being equal to 0. Just like in my previous factoring problem, I'm now going to set each factor equal to 0. And I will solve these. So I'm going to have minus 4. Uh-oh. Then I take the square root, and I get x is equal to plus or minus. And the square root of negative 4 does have an answer. So remember, this is negative 1 times 4. And the square root of negative 1 is our very, very, very special number. Who is it? I. So this is going to be 2 for the square root of 4, I. Right on. We haven't seen an imaginary number in a while. The other expression, the 2x minus 5, I kind of moved into. I add 5, I divide by 2, and I get 5 over 2. So I've got x is equal to plus or minus 2i and also 5 over 2 as my final answers. Very cool. Looking at 88, I see that this is a quadratic trinomial that I want to factor if possible, but I'm not feeling optimistic about factoring. I look at this and I see, okay, I've got 3 here and 6 here, and it's all positive. 1 and 6, 2 and 3. Is it going to happen? For factoring, no. When factoring doesn't work, I go back to my old friend, the quadratic formula. So the quadratic formula is a special formula that I have memorized. It is x is equal to, so it is the solutions, negative b plus or minus, oh, my computer is thinking again, the square root of b to the second power minus 4ac, and then the denominator over this whole expression is 2a. So identifying a, b, and c will be helpful. A is 2, B is 3, C is 3. This will be really easy. We're just going to plug those numbers in. So that's going to say equals negative 3 plus or minus. Now I'm going to square the B to get 9 minus 4 times 2 times 3. All divided by 2 times 2, all divided by 4. So now I'm going to do my side work. That's going to be 9 minus 4 times 2 times 3. That's 8 times 3. That's 24. 9 minus 24 is negative 15. We agree with that? That's mental math. That's hard for me. I don't do subtraction in my head easily. Seems right. So again, we're going to have an imaginary solution here. That's negative 15 in the radical, which means, again, this is negative 1 times 15. So the 15 isn't going to simplify, but we're going to have the imaginary number I show up for that negative 1 part. So our answer is negative 3 plus or minus I rad 15 over 4. And this represents two distinct answers for x, negative 3 plus I rad 15 divided by 4, and negative 3 minus I rad 15 over 4. Great, we solved for x. All right, 89, we're feeling a little better about that. That's an absolute value function. And remember, for absolute value, it looks like a V shape when we graph it. So we do expect to find two solutions most of the time. So looking at this absolute value, we're going to first start by isolating the absolute value itself. So I'm going to subtract 3. That gives me the absolute value of 2x plus 5 is equal to 4. So there are two possibilities of values that have the absolute value or distance from 0 of 4 units. And that's 4 and negative 4. So we're going to say equals to 4. And over here equals to negative 4. So it's 2x plus 5 and 2x plus 5 for both of those. So if 2x plus 5 is equal to 4, then this would be true. And if 2x plus 5 is equal to negative 4, since it's in the absolute value, we evaluate that to get positive 4 also. So now subtracting 5. I have 2x is equal to negative 1. 2x is equal to negative 9. Dividing by 2, I got my two answers. X is equal to negative 1/2 and negative 9 over 2. So now we're going to swoop on down to number 90. Ooh, number 90 is a rational equation. So I just want to keep in the back of my mind the values that x cannot be equal to at the end of the day. X is not going to be equal to 0 or 1 because both of those values would create a division by 0, which we all know now creates an asymptote, an undefined value. So we're not going to have those. I'm trying to solve this, and so in order to do that, I'm going to need to find a common denominator. That least common denominator is going to combine all the denominator factors, x times x minus 1. Then I multiply by the LCD so that I can cancel out the denominators. So when I do that here, the x's cancel and I'm left with the x minus 1 in the numerator. Or the x minus 1 cancels and I'm left with the x. And on this side, nothing cancels. So I'm imagining that I'm taking that LCD and I'm multiplying it to every single part. So now I'm going to distribute. I have 12x minus 12 plus 9x is equal to negative 3x. Let's see. Nope, negative 3x to the second plus 3x. Oh, dang it. I thought this might be an easy one, but I'm seeing that now I have a quadratic equation to solve. So seeing that I have an exponent of 2 here, that tells me that this is a quadratic equation. I need to make one side equal to 0. And so I'm going to add 3x squared. And I'm going to subtract 3x from both sides. That's going to say equals 0. And I have 12 plus 9 minus 3, 12 plus 6. We've got 3x squared. 12 plus 6 plus 18x minus 12. All right, cool. So I'm looking at these numbers and I see that they can all be divided by 3. That brings me a lot of joy. And because this is in whatever, we'll just factor it like this. We've got x squared plus 18 divided by 3 is 6x minus 4. Oh no. Dang it. Okay, I hoped I had made a mistake. 4, I'm not seeing this being factorable. So again, I've got to go ahead and use my quadratic formula. Okay, I already can tell this isn't going to factor. What's going to multiply to 4 and add to 6? Nothing. Right? So let's do it. A is equal to 1, B is equal to 6, C is equal to -4. So that quadratic formula, I had written it down over here. Negative B, so that's going to be -6 plus or minus 36 minus 4 times 1 times -4, all divided by 2a. So just divided by 2. I see that I have a 36 plus 16 inside the radical. That's going to be 52, which unfortunately needs to be simplified further because 52 is 4 times something. So that's going to be -6 plus or minus 2 rad 13 over 2. So if I separate the 2 into both of those terms, it's going to let me divide those coefficients, giving me my final answer of x is equal to -3 plus or minus rad 13. You might be wondering, oh, what about the 3 out front? Well, that 3 didn't have an x in it, so this 3 here has nothing to do with the answer for x, fortunately. Dang, that problem really surprised me with all the extra work. All right, 91 is a square root problem. This one's going to be much faster and easier, I can tell. I'm going to isolate the square root symbol with a +4. I've got the square root of 3x minus 8 is equal to 7. I get rid of the square root with square power. I have 3x minus 8 is equal to 49. I add 8. And I have 3x is equal to 57. And I divide by 3. Now 5 plus 7 is 12. I'm adding the digits together. So 57 is divisible by 3. I just don't know what it is. So we got 2. We'll go in 1. And then we'll have 27, 19. X is equal to 19. Yeah, that one was way better. I didn't need to do 2 formulas. Very cool. 93, I look at that and it's cube root. This one's going to be even faster because I can see that there's less going on. I love this one. I start right away by getting rid of cube root with the opposite operation, which is cube power. That gives me x plus 7 is equal to 64. I subtract 7. And isn't that interesting that this same number showed up again? 57 is our answer. Very good. Let's move on to number 93. Okay, 93. Oh, cool. I thought it was a sum of two cubes because 64 is 4 to the third power, but that's x squared plus 64. So in this case, I'm just going to solve for x with opposite operations. Let's subtract 64. That gives me x squared is equal to negative 64. Now we get rid of square power with square root. When we're solving for x and we take the square root, we have to remember we're looking for two answers. So this is where we use the plus or minus. Forgot my equal sign. And then here's 64. It's -1 times 64. So we're going to have our imaginary number I in this answer, and the square root of 64 is 8. So it's plus or minus 8i. Huh, very cool. All right, on 94, this is a log equation. And in this case, I've got to remember how logs and exponentials work together. It's log base answer is equal to the exponent. And that's very closely related to the base exponent is equal to answer form. As it is now, this problem is unsolvable until we convert it to its equivalent form. So the base is 3 and the exponent is 4. 3 to the 4th power is equal to x plus 2. Now we can see, oh, there are just 2 more steps. 3 to the 4th power is the number 81. It's equal to x plus 2. So then I subtract 2 on both sides and I get that x is equal to 79. And so we've got to have that understanding about logs to do this one. Let's check out 95 and see if it's similar. Yes, it is. 95 is similar, but not the same. 95 is an exponential equation. I don't need to use logs to solve it because of 9 and 27. So 9 is smaller, so we start there. What's a different way that we could write 9 with a base and a power? We're going to write it as 3 squared. That's right. We're going to do the same thing with 27, knowing that we want to write it with a 3, and I know that we can. We're going to write that as 3 to the 3rd power with the k plus 5 on the outside. What we might not have remembered is that these powers multiply. So I'm going to add in a parenthesis here to remind myself to distribute the 3 when I'm solving this. When I have the same base is equal to the same base, but the exponents are different, then I just say 2x, nope, just 2 actually, is equal to 3 parentheses k plus 5. Now I'm going to solve for k. I did say I was going to distribute, so I will. Then I'll subtract 15, giving me -13 is equal to 3k, and divide by 3. K is equal to the fraction -13 over 3. Well, that's a surprise. So if we have an exponential problem and we think we could write them with the same smaller number base, then it's good if we do that, because using logs can be kind of tricky. Got to use those many formulas. So looking here at number 96, this looks like a problem that I won't be able to use the same base. I'm going to isolate the exponential expression. I'm going to add 7. And that's going to say 5 to the x plus 2 is equal to 30. And even though I could write 30 as 5 times 6, I can't write it as 5 to a power of something very easily. So instead, I'm going to need to use logs. This is the base, this is the exponent, and this is the answer. So that's going to be log base 5 of 30 is equal to x plus 2. For this expression, I'm going to leave it like this, but I'm going to translate it to the base change formula. The base change formula, you see that I drew this line here to remind myself which number goes in the top. It's log 30 divided by log 5. This is the only time we see log divided by log. This is just what you plug into your calculator. And that's equal to x plus 2. So when I subtract 2, I get my final answer for x. This is the exact form. In order to go further and get a decimal approximation, you'll need to use your calculator. If you don't have your calculator out, I suggest that you get it out right now to remember how to use these formulas. I'm getting mine. So I'm typing into my calculator log 30, closing the parentheses, then division, then log 5, closing the parentheses. I hit enter to finish that operation. I got 2.113, I subtract 2. And I got 0.11328. I can't remember how many decimals we say. I thought it was 3. So 1, 1, and then it was 3, 2, so just 113. Ben. Typically we leave it as exact. If this is exact, this is the exact value. Whereas in my calculator, you saw that I didn't write down the full number. And my calculator doesn't actually show me the full number. All right. 97 is another rational equation. Here, the LCD is a lot easier to calculate. The LCD here is 2x. Whoa, okay, my computer thought that I was wrong, so whatever. LCD is 2x, so x does not equal 0. On this one, I'm going to show that work of 2x, 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 and we'll see that the x is canceled, the 2x cancels, the x is canceled, and I'm left with 4 plus the whole thing canceled, 3. Really, that's it? Yeah, okay. And then we'll have 2 parentheses 4x minus 5. So I'll distribute over here to get 8x minus 10 is equal to 7. Oh, good. X will not be equal to 0. Now add 10. 8x is equal to 17. Dividing by 8. I get this fraction for x. I'll leave the fraction in the form that I found it. This looks great. Oh, we're almost done with this page. 98. Okay, we're solving for an exponent, so we'll probably need to use logs unless it works out that the other side can be written with a base 3. Let's take a look. It doesn't look like that's going to be the case. I subtract 14 because I'm trying to isolate the expression that has n. That's 2 times 3 to the n power is equal to 60. I divide by 2. I have 3 to the exponent n is equal to 30. And oh my gosh, are they trying to trick you? They sure are. 3 times 10 is not the same as 3 to an exponent. We don't know 3 to what power gives me 30. So I'm going to write this in log form. Log. The base is 3. The answer is 30. The exponent is the letter n. And so in exact form, that's going to be log 30 divided by log 3, which is the decimal approximation. Oh, we've got our calculators out still. Let's plug that in. It's 3.0959, so 3.0959, so 096 when we round it. Oh, sweet. So we've still got 5 minutes. Let's finish and turn the page and see what's going on next. $99. Oh, we love it. ln, log natural. So I see a log plus log. So that tells me I'm going to need to multiply 2 and x plus 3. So combining this to the single ln of 2, and let me think, 2x plus 6 is equal to 5. Now with ln, I want to remind myself how to do that. And I remember that ln is log base e. So just to exaggerate that, I'm rewriting it so that I can visually see the base, because when it's in this form, it's much easier for me to identify the base, the answer, and the exponent. So here's the base, here's the answer, here's the exponent. So the exponent will be 5. This will be e to the 5th power is equal to 2x plus 6. Now I'm just going to solve for x. My answer will have e to the 5th power in it. I subtract 6. I have e to the 5th power minus 6. Then I would divide by 2 over 2 as my answer for x. And then I'll put the decimal approximation for that. So in order to use that e to the power button on my calculator, it's in the blue writing on mine. So I need to hit second. Then I hit that button and I'm accessing, and it shows me I'm doing e to the power. So I put in e to the power of 5, close parentheses, minus 6, and then I finish that operation by hitting enter. Then I divide by 2, and I get 71.20657955. So rounding that, 71.20, it's 6.5, so 7. So here I've got both my exact and my decimal approximation. Ellie. B stands for base, A stands for answer, E stands for exponent. Log base answer equals exponent. I have this pattern totally memorized because I'm identifying which part is what, just to help myself. Because when I translate it, I need to remember who's who. So to do that, that's what I do, is I label them because it helps me put them in the right spot. I don't want to accidentally do 5 to the e power and just get mixed up. So I just slowly go through it and label each part. All right, you guys, we got 1 more minute. I don't think that's going to be enough to do problem 100. So very nice